All right, welcome back. And I trust you've enjoyed the bit of learning you've had now in the last couple of modules. So let's just take a look what you've got through. Okay, module 1, you've gone through both getting an understanding of Janssen, the company in Switzerland, why steel has got great benefits over other materials. You've had a look at DocuCenter, and you've also looked at fenestration types and norms. And now you've gone through basically all the products from the safety systems, fire, security, bullet resistance, and you've also done the non-insulated and the insulated building systems for both residential and commercial use. You've gone through Yanisoft with Luke, and you're probably enjoying some of the program and the benefits it can give you as a metalworker. Now, the next part today is part 4.1 of module 4, which is fabrication, finishing, and glazing. And again, due to the current situation in the world, we've recorded the training that we had in the workshop, and we've done it as best as we can. So I trust you enjoy some of the things that you will see in the factory that Andreas will take you through for the cutting, the welding, and the grinding, and so on. A bit later, you'll look again at surface protection logistics for a South African context, whether you're at the coast in Cape Town or whether you're in Joburg. And then the last module, as you're aware, is the project for accreditation. So well done, you're nearly there. And for now, we'll hand over back to Andreas. Thanks, Andreas.
Okay, so entering now our workshop. Reto is here, my colleague, who I already introduced you to. Reto he's a professional metal worker, and he is responsible for producing the prototypes and samples, like the ones you see here. This is his main job. He will walk us through the process of cutting, welding, grinding, and finishing a frame. I want to just briefly show you what he has here, how his workshop is set up. He has a large computer screen here with the access to the DocuCenter and all the documents. So this is really his source of information besides a standard computer laptop here. Well, some tools that he uses. He has a welding table like the one you see here. It's a small one, 1 meter by 1 meter, the solid steel hole table, which we will use later on. These tables come in different dimensions. He has a small one here because he only works on small structures. Here he has a couple of more of these. I don't know how you call them. These tristle. Okay, trestles. And a welding table, a nice new welding table, which pivots. We will show you in a moment. So that's pretty much his equipment. Welding machines installed up above under the ceiling in order to move it all around the table. So here you don't have to roll anything. You don't have to move anything. Air extraction or fumes extraction unit. All the welding stations have it here in our workshop. A couple of more machines to grind, to sharpen the tools that he uses. A little older mill, like a hand mill or a copy mill, we call it. And that's basically his setup. We will begin our exercise in our innovation center, our technology center. This is the door that leads to this hall. This is the new hall I described to you, where we have the testing wall. You see the door here. This is a full panic door with the push bar, based on Yanisoft 2. So this is good for 30 minutes EI insulated fire stop. So there is an insulation thermal break here, and a push bar. Now entering the hall. We have two sides. On two sides, we have the FIS facade. I would say the hall is roughly 80 by 60 meters, no, maybe more, 100 by 80 meters. And the facade plays the role of two walls. The facade is built or is based on a 250 mm profile. This is our most massive profile that we have. It can carry glasses up to 1.8 tons. These glasses are not as big. They weigh probably some 600 kilos. But the special thing about these glasses is they changed the transmission of light. You can change the electrical field in these glasses, and they become bluish or dark bluish, depending on the sun radiation or the strength of radiation sun.
What they call electrochromic.
So this is a prototype facade. We got the glasses from Sage Glass. This is a company that belongs to Saint-Gobain, the biggest glass producer in the world, I guess. And they gave us these glasses just to try them out, and they do work fine. Here, what you see is it's a storage unit for small parts, like so. And my colleague is just checking or taking out some stuff. This is a continuous band, so this travels up and down. Cez, könntest du das kurz bewegen, dass ich das mal zeigen kann? So this is how it runs. It's a very, they love it. You can store a lot of stuff here.
Oh, the unit, brilliant.
Yeah, this is how it works. And it's, I would say, some 6 meters high.
No way.
Lots of different stuff stored in a very small place.
Dankeschön.
Das geht nach Südafrika jetzt. Okay, here, the other side of the hall. Here we have the machining area where we have saws, a single head saw and a double head saw.
Yeah.
We will work on the double head saw. So this allows us to cut the profile on both sides at the same time. So 245-degree cuts. The single head saw cuts only once, but it has more possibilities when it comes to angles. Here you can adjust any angle on the blade. The angles are limited here on the double head saw. We will just we'll talk about this in a second. Behind the saw, you see the milling machine, the CNC AF310. This is our top of the line milling machine that we use. 10 tools, 5 axes, 3 sides of the profile processing. So basically, wonderful thing. They're both connected. The double head saw is connected to the data systems, to Yanisoft for that matter. You can, after planning in Yanisoft, you can send the data packages to the saw. It will create a cutting list. The cutting list is then transferred into labels. Labels are placed on the cut profiles, and then the profiles are transferred to the CNC machine. The CNC machine recognizes the profile and notches out the openings that are needed for locks and hinges and so on. So it's a fully linked and automated process. Okay, but first of all, we will choose a profile. We will work with we will take a Yanisoft profile, so an insulated profile. Also, this storage. Okay, here we have different profiles. These shelves are you can actually slide them to the side, and if it's needed, you can lift the heavy stuff with cranes, just like that. We have cranes all over the ceiling. There is 2 large cranes, so every corner of the hall is accessible. And if you have heavy profiles, you can lift them with the crane. There is actually a limitation on weight. 25 kilograms is the most a person can lift without mechanical aids here in Switzerland. Okay, we'll take a profile. Okay. Yeah, that's the Yanisoft profile. All the profiles are marked, so you will find on each profile the description, item number, the name of it, production date and time. So basically, this is the basic information. Okay, so we will start with a cut. We'll take one profile, cut it 45 degrees on both sides, and then still cut it in half, and we will create we will actually make a corner of a frame. On this machine, on this double head saw, we have a so-called micro lubrication system. It's a impulse lubrication system, so it just sprays little droplets of lubrication agent on the blade. The profile stays dry and clean, so you don't even see the oils Saves a lot of work. Alternatively, we can also use the standard publication, which is continuous, but we don't do it just for the purposes of cleaning afterwards. We don't need it here. If you cut full profiles, solid profiles, then probably the continuous lubrication is better. Okay, then we will approach the machine, double head saw. It's a 2-finger or 2 hands operation, just for safety reasons. First of all, Reto will input the item number of the profile, so the machine recognizes it, and it will adjust the parameters, the cutting speed and the cutting progress. So he chose the profile. The machine recognized the profile, and it shows you how you should position the profile in the saw. These 2 axes is the back side, and you basically recognize how to position the profile. These would be the 2 sides that I just showed you, and that's where we have to place the profile. Then we have to before we put the profile in, we adjust the angle, so 45 degrees, or in this case it's 135. So that's the 180 minus 135 gives you 45. So we can actually change between 45 and 135. So basically 45, 45 on both sides. If you need sharper angles, then we use the single head saw, which is but can be adjusted continuously without any limitations, from 1 degree to 197. Okay, now the length of the profile, he inputted 1004 millimeters. The 4 millimeters will disappear when we cut it in half. The 4 millimeters is the width of the cutting blade on the single head saw. So we will be left with 500 and 500 millimeters profiles. Okay, the machine starts to adjust. Then this is the first step, that what he needs to use 2 fingers. And what happens is the machine adjusts itself. It will come together to accommodate the profile. You adjust the angle. Here you see the two slots are where this blade comes out. Position the profile accordingly. When working with insulated profiles, which feature the insulator part, we are actually better off, or on the safe side, when we use supporting blocks like the ones you see here. These are aluminum pieces which will avoid squeezing or deforming the profile due to the softer part on the insulator side. Okay. In general, for each system that we have these supporting blocks. The guys here in the workshop actually painted them in different colors to make them nicely recognizable. In the documentation, technical documentation, you will find the supporting blocks for each of the systems, and they all have item numbers. Alternatively, of course, you can make them themselves. Just cut a piece of aluminum block. And this, again, we use for all the insulated profiles, not to deform them, to get a straight cut. Okay. Now the next step is clamping. The profile will be clamped from in both axes, in 2 axes. So there is 2 clamping studs, which you see here, and a clamping device right here. In addition, well, this will be actually clamped by the stud that will lower down and will not deform the profile. Okay. All right. All right. So it's all set now. All aligned. It's solid, not moving. So we can start the cutting process. So again, 2-finger operation for safety reasons. Okay. Yeah. And we start. And I will just try to shot a close up here. Okay, now before the blade moves back, the profile is moved. You see here there was a gap created. It does that to they call it to air the profile and to avoid a conflict between a conflict between the blade and the edges of the profile. So just to make a smoother cut. Yeah? So here we have both cuts are done. And let's have a look at the blades that we use, because it's also a matter of choosing the right blade. This is the blade for the single head saw. It's a 4mm, 280, I believe, teeth. That's the one for the double head saw. That's a 3mm blade with also 280 teeth. Then we have a couple of other discs here, or blades, for different materials, for stainless, for even for for aluminum there is different ones. Yeah, so different materials that they use. For the full profiles they also use different blades.
Between each blade,
because what they also do, they also cut this type of profiles here. This is sometimes what they use for the testing process, to produce, actually to modify the testing wall, which you see here. This is actually the entrance to the testing wall. Okay, now we have cut the profile. You see, 245 degrees. If this was let's say one side of the frame, this would be already done. For our purposes, just for the exercise, we will still cut it into half. Okay, this is fully adjustable without any, let's say smooth adjusting without any steps. So you can do it on both sides, so sharp angles on both sides. There's no limits here. 180 degrees. Hi. Yeah. So again, here we have a clamping action here from both sides, so we will use the blocks not to deform the. And then so this would be the from up to down clamping action, and this will just clamp it towards the back of the saw. Okay, this is the measurement device. This is electronic measuring tape. So we're going for 500. Well, 0.1, that's okay. Yeah, there is the plate, the limiting plate here. And then again, the supporting blocks, not to deform the profile. Here you can adjust the speed and the progress again. Yeah, that's the speed, or the progress of the blade, how fast it actually lifts. It comes from the bottom of the machine and it moves towards the top. So this is how this machine works. Okay. The lubrication system here is again a micro lubrication system, so just droplets of emulsion on the blade. Okay. This machine is a bit slower because the blade is thicker.
Speed's probably adjusted when stuff is broken.
So this is the corner, 45 degrees, and this is, we will finish it, we will weld it, grind it, and show you the result. I will just briefly give you a short tour. Ich zeige noch mal den Rest der Halle, just to show you what else is here in this building. Well, several working stations, several storage places also. We always have these shelves on the side, right next to the small part storage. We have an aluminum workshop, so this is a totally separate area here with Schuko machines and aluminum profiles. So it's basically just a separate area. We don't mix it, and it also shows a little bit the proportion between aluminum and steel here in Switzerland. We sell roughly 15% of aluminum, and the rest is steel.
Wow.
How many people are working in there, Andrea?
How many
People are working in the work.
In this area, I would say some 20 people maybe. There's more stations here, as you see, the bigger ones, some prototypes. More stations here, welding machines all up in the air, nothing on the ground. More working stations here. Yeah, more stations here. And behind this wall, we have the test wall, which I'm actually not allowed to enter. I don't have access to this area, but what I can show you is well, some of the elements that are waiting for the testing process. It will be then just put inside. We can do here wind, rain. We can do pressure, so air pressure combined with rain, and the RC, the burglar resistance test. Yeah. All right, so this is it. This is it's designed so that the flow of material is optimal here in this area. Very short distances between the storage area and the processing stations, and then immediately yeah. So no transportation here. No transportation time needed. Okay, good. Then we will continue. What this facade also features is a sliding door, which you see here. It's a 5.7, I think, meters high. Reto will activate it a little bit just to show you. It's an electric sliding door.
Oh, wow.
For the trucks to open. And we have another swing door. So this is it. This is for the trucks. And we have another one, just a double leaf door with almost standard handles. This is not in use, but you see the handles here. Also no lock, these are permanently locked. And the door is again 5.7, I think, both doors.
Oh.
Yeah. So this is it. And also here, a big screen for the documentation. This is an aluminum sliding or lift and sliding door. Yeah, so this is the Schuko world.
Brilliant.
All right. So back to Reto. Nee, es war schon gut. Ja. All right. Okay. So this is a, ist das jetzt verzinkt oder nicht? Nee, ne?
Es ist ja auch nicht, aber muss es auch gerne nicht sein.
Nee, aber even blank. So this is an example of a blank profile. So this is raw steel. It's covered with oil, just for protection, you know, anti-corrosion purposes for transportation. So what Reto does is he cleans it up first. Yeah, that's always a step that he does. In between, also clean the chips, clean the impurities. This helps, and it doesn't or actually increases the quality of your work. Now, what he will do is he will weld the corner. Before he does it, however, he needs to chamfer, I think it's called, to cut the edges of the profiles to create a channel, you could say. And he will draw it on us. We do this on all profiles, well, on all standard steel, carbon steel profiles. Im rostfreien machst du es nicht. Ne? Stainless steel, you don't do it. So stainless steel doesn't need it. It's I think the temperature is higher and the welding material just penetrates the both profiles much better. If you did not chamfer it, this is what you would get, and your welding seam would be created on top of the two touching walls. It would probably penetrate a little bit, but it will stay on top. If you grind it off now, you would only have a weak connection between the two elements. Okay?
Okay.
So what he does is he chamfers it, creates the channel or the recess, and thus he can the material penetrates all the way through, and when grinding, you don't well, diminish the quality of the connection. It's important. I have seen lots of metal workers that don't do it. They don't even know about this. They I don't know, for some reason don't do it. But it's a necessary step. It's shown also in all our documentation. So this is what he will do. He will use an angle grinder, and it's a quick step. So standard grinder. Yeah, 45 degrees. A millimeter depth. So that's what he removes. Okay. That's it. Both sides, we will be welding both sides, and not the inside. The inside does not need to be chamfered and will not be welded. Only on the let's say supersized frames, it's recommended to weld the inside. Standard-wise, you leave it just like it is. The outside welding seam is good enough. Yep. Now, of course, we would be working in real life on a full frame. This is just a corner, but it will be just 4 times the same processing steps that we will do now. Okay. Now, to connect it or to align well the profiles, we will use the welding table. And we'll see the advantages of this little device here. It's a small one. This comes in different sizes. You can customize it. This one is, was ist das jetzt? 2? Okay, that's only 2 by 2.5 meters. The standard size is 3 by 2.5, and it can go, I mean, it's really up to the customer how big he wants him. It's doable. I mean, you can do 3 by 4, no problem. The table features an electronic measurement system. If it's visible, down to 0.1 millimeter, but also has the digital one. I mean, not the digital, the analog one. So just eyeballing.
Yeah.
So here you can adjust or position the profiles, assemble the frame pretty much, and once it's clamped, you don't have the need to check the dimensions anymore. It will stay put, basically. So it saves you the checking of the diagonal and so on. Okay, he will do, of course, here a little improvisation, a little trick. We will only have a small corner, so he pulls the 2 plates together. The plates are made out of special steel. These are nitrated, I think they call it, so nitrated. So the droplets from the welding machine will not stick to it. Okay. Yeah. Position the corner. So here, if you did a good job on the cutting, you will get the results just like we did. To make it even more precise, again, Reto will use the supporting blocks or the clamping blocks, and one on top. That's actually a key part. These the flush the flush surface that you want to get. This is a key, and the small block serves this purpose.
Wichtig ist, dass wir das Profil immer rausziehen. Also wir wollen ja nachher auch das richtige Ausmaß haben, das wir hier eingestellt haben.
What counts here, or what you need to pay attention, is the outside dimension always. This is what's measured. And clamping always in 2 axes. Top down and sideways. An important device is this plastic hammer, just for the final adjustment. It's nice and handy. Yeah, quite a few clamps for a small piece of profile, but on a full frame, this would be, of course, looking a bit different. Then one final check. He's using a small ruler here, just to make sure that we are totally flush, and we are. The better job you do here, the more precise you are here, the less afterwork or correction work you will have afterwards when grinding. Okay, now we will what do you call it? Tug weld it first. Why spot weld it? We don't do the full welding seam at once to avoid the deforming of the profile. The more heat you introduce into the profile, the more deformation you will get. This is natural. This is physics. Just steel, how it reacts to heat. So to avoid this, we will first do the outside, do the spot welding on the outside, and then move. And then, of course, all 4 corners ideally, and then move from the inside of the profile to the outside. This is the direction of welding. To minimize the heat transfer to the profile, you want to get the heat out of the profile. So this is, again, to avoid deformation. Okay? Yeah, he's using a 0.8 millimeter wire and an automatic, welding machine, I guess. That's it. And he changes the wire when he welds stainless, and he takes the stainless steel wire. Okay. Yeah. So he's spot welding it first. Okay. So he did just four spots here, as you see. Distance some 15-20 millimeters, and then. Yep. Okay, that's it. That you would do now to the next corner. You would just go around, do the next corner, third, fourth. In the meantime, the first corner would cool off, and then you would be ready for the final welding, the continuous welding seam. Now to spot weld the other side, which is still untouched, Reto will rotate the table. It has a motor, rotates 225 degrees, so you can reach the both sides of the structure. And again, a little control here. Is everything still in line? It is. Perfect. And then first spot welding, I mean, just a few dots, and then the full welding. Okay.
Der nächste Schritt wäre dann, wenn ich bei allen Ecken gemacht habe, wäre der nächste Schritt schweißen. Darum wir auch wieder zuerst ausschweißen und dann wieder auch, wie du siehst, das will ich schon innen nach außen.
So once this is done on all 4 corners, we're ready for the continuous welding. And then again, he will start here on the edge, on the outside, to minimize the heat transfer, and then again move from the inside of the profile to the outside, and do this from both sides. Okay. done. You see the heat, the hottest spot is on the outside of the profile. So thus we minimize the deformation. Then we'll turn it again. So same procedure here, all four corners now, and then pivot it again, rotate it again, and finish the other side. Now you see why clamping well is important. Then this whole structure doesn't move. There is no need to checking the dimensions anymore once this is well clamped. So we will remove the supporting, the clamping block on one side from the upper side. And then again, just moving from the inside to the outside. All right. And you can see the finishing, the welding seam is nice and clean, pretty much. No pores, not much smoke. This is the ZF100 surface. No, sorry, I'm saying bullshit. Sorry, no, this is not. But you would see it. It would look pretty much the same. We will do a little comparison of the two surfaces. You will see the difference then. It looks similar. So the ZF100 is almost like blank steel. Okay, so this is the picture, as you see, welded all three sides. The inside is left unwelded, unless you have a extra size frames. So the catalog sizes do not require welding on the inside. Just if you are, on a project size project. Element. Okay, that's a good point. What Reto is saying is the problem could be if you weld on the inside, you have to grind it really well. And where you position the glazing beads, here you have to again clean the corner. So grind it off so your glazing bead fits nicely. Yeah, there's no obstacles for the glazing bead.
Actually, in the ones we were making in South Africa, yeah, we had that problem. The welding bead got in the way of the glazing bead.
Yeah, so this would be, on the extra sizes, the XXL sizes, it would be an additional step. Wie machst du das weg hier? Das ist mit der Pfeile oder? Wenn du jetzt innen...
Ja, wenn du jetzt innen würdest schweissen, dann würdest du nicht ganz bis raus. Und dann würdest du dann eine Art Glasleiste ausklinken.
Okay.
Weil du aber nicht mehr schlau verschleifen.
What Reto is saying, it will be very difficult to actually remove the welding seam from this corner. Yeah. So what he would do, if he was to, if he was, welding a large frame, he would not weld it all the way to the top, but rather leave the last piece, let's say, unwelded, and then notch out the glazing beads in the same way. So it will accommodate the welding seam, which will stay in place. So this is how we would go about it. Yeah.
Okay. Yeah.
So you solve it through notching out the glazing bead.
Next Punkt wäre das Schleifen. Ich fange da an mit
einer. You can do either. It's up to you.
The next step is to grind off the welding seam. Reto will start with the grain 80. Well, you probably know better than I, these discs come in different grains. The higher the number, the smaller the grain. So this would be a 120. 120 is the one he will finish it with, and he will start with the 80, grain 80. In the past, actually, the technology of these grinding discs has progressed tremendously during last years. Today, it's not necessary to start with a really low grain, like the 36, which was necessary in the past. So this would be the 36, the really rough one, but it removes a lot of material. And today's discs actually you can start right away with the 80, grain 80, and it will be just good enough.
Wow.
3M makes the best grinding discs. They are a little more expensive, but they last longer. So in the end, I think you are best off just buying this good quality grinding discs. And the Cubitron is the product line, which we use here and with lots of success, and everybody's happy. So just a little hint, if you want to try that, it's recommendable.
It's German.
Also zuerst mal
Okay, first he will grind off the outside of the profile and then the up and downside. Important when we grind, if you grind the welding seam on top and on the bottom, to move the grinder from the inside of the corner to the outside. Thus you have a nice support on both sides. The grinder will not dance around, will not bounce around. If you did it like this, you would probably damage the corner. So always position it on the inside. Use the two sides of the frame to have a nice smooth and straight grind. Okay.
Okay.
Okay. So the outside first. And then the top. And again, the movement, straight and stable movement. And that's it. Nice and smooth. You still see the patterns of the disc, so we will have to actually get rid of them. As long as you can feel the structure with your nail, it is likely to be visible after powder coating or after coating. So you have to get to a point where you don't see any patterns, you don't feel any pattern. It is a little bit dependent on the type of paint you're using. Wet paints will show more impurities, more more patterns. I don't know if you can see this. This would be actually an 80. It's hardly visible here on this one. Yeah, that's that. You can't really see it. There is still some patterns visible here. Very little. Unskilled, I would not see it, but an architect's eye would probably. So from 80, we will go one step up to 120 and then finish it off with an eccentric grinder, not to have anything. Before we go further, though, you see here that we created a little. We closed the gap. So here we have a little droplet that we need to get rid of before we continue, and we will do it with the file. If we were to scratch the surface now at this point using this tool, it would be not a problem. If you continue grinding and then scratch the surface, then you have to start again from from the lowest grain to get rid of the scratch. So the file has two sides, one smooth side and one rough side. We'll use the rough side, and the smooth side is not to damage the side you're not grinding. So we'll go from both sides. So you want to get back to the 90-degree angle. At the same time, the edge. All right. Now, if this was the outer frame, let's imagine this is the outer frame. This is the visible part. The other side would be actually attached to the wall, so it doesn't matter. You don't have to grind the the side that is touching the wall in the end. So one less step. Okay. 20. Okay, so the next step, we'll take the grain 120. The 80 is now gone, 120 is on, and one more grind here. So not much smoother now, but still not perfect. I can still feel the pattern. So to finish it off nicely, Reto will take a eccentric, polisher actually. This is the it's air-driven, pressurized air, and as you see, it spins eccentrically.
Yeah.
Air hose. Now, no more patterns. Uniform surface almost ready for painting or coating.
Quick.
So this would be the grain 120, which is now totally smooth. With 120, you don't see anything anymore.
Beautiful.
Okay, and still one more check. He loves this type of check. Still very flat. No deformation, unless you would have to correct it at this point, if there was any.
Beautiful.
It is crucial because sometimes, you know, it happens. It happens. It's not like, especially if you're not skilled enough and too much heat in the profile, it can actually happen.
Yeah.
You'll actually pick it up very quickly.
Do you guys have any questions so far? Is it coming over clear? Coming across
Very.
okay?
Yeah, thanks for the awesome tutorial.
Okay, super. Okay.
Very good, very clear. Enjoyed it.
Okay, so next step will be we will position or install the glazing beads. Let's imagine we already glazed the. Before we glaze it, we can drill or set the studs.
Andreas, a quick question on the polishing machine. What did you have on it? What was the polishing material?
Ja, this is, kannst du nochmal dieses Cubitron von dem Exzenter zeigen? This is also a 3M product. It's also the Cubitron line. Okay, this is the box actually. This is the box that these discs came from. It's the Cubitron 2. Here you see the, it's called 80 plus. Just there is no defined grain on this. It's not really grain. It's rather like a fabric slash sandpaper.
Okay, with you. Cool. Thank you. Beautiful little polisher. That's good.
So is that possible, or you can use it?
Das passt. Er wollte das hier wissen. Also.
It'll wear out actually.
Okay.
So it's a bit
All right.
sort of stuff. But he's saying that the 3 of them last quite long.
Okay.
And then that's eccentric, so it does this, so you don't get those circles.
Bitte? Ja, gerne. Kannst du gerne aufrufen? Okay, Rato will show you something that what he will do next. He will position the studs using the setting machine, the one you see here, the one I showed you already. From the documentation, the technical documentation, this is the one that's sticking on his door, but he will pull it up on the computer in a second. You actually see the distances between the studs, how to set them from the corner. The distance is usually 70 or maximum 75 millimeters, and between the studs is maximum 300 on a standard frame. Firestop, I think, has a smaller distances, 250 or 200. I would have to look it up. But then again, this is how we tested it, and just more studs gave a better result on the fire test.
Okay.
On the computer, again, very handy. You can see the same, pull up the information, zoom in, and he has all the information. It's 70 millimeter from the corner. You also see the the distance between the studs. The stud number is here, the item number. You have also the glazing possibilities, the aluminum studs, distance tapes, or gaskets. Yeah, so all the tips and tricks, how to do it. Yeah.
Okay.
Okay, so before he starts drilling, he will, just to make it easy for himself, maximum 70 mm from the corner. So he will just make a mark here, and then every 300. So we can only set 2 studs here on each side, but again, this is, I think, representative for a full frame.
So it's actually important when you get down to the architect specs for plants, thickness of
Okay, so that's the fixation set, which I showed you already. It's based on a electric drill from Fine. Fine is a market leader in metal drilling machines. I read they make good stuff, good machines, and this is just adapted to our purposes. It's an older set already, but it does a good job and doesn't need any changing. as a magazine for the screws if you're using self-drilling screws. Or you can take it out and just put a drill bit in if you want to drill, for example, on stainless steel, if you're using the method, the stud system. Then you drill, pre-drill, and then just screw in the self-tapping screws. The magazine itself is easily adjustable. Basically, there is two settings in the Janssen world for the stud system. It's either 7 or 9 millimeters. And again, these millimeters is the distance between the edge of the profile and the center of the head of the screw. It should be 9 millimeter for 95% of the glazing beads, and 7 millimeters for the smallest glazing bead. If you're installing thick glasses, then you would have to use this, of course, on some systems, on the Anisol most of all, you would have to use a thinner or a thinner, slimmer glazing bead, and for that you adjust the setting the distance to 7 millimeters. So it's either 9 or 7 in a few cases. But you can also do it without any steps. It's individually adjustable. If you want to create an offset here with the glazing bead, or you want to have it flush, you can adjust the setting on the tool. If you do the 9 millimeter setting, you will notice that the glazing bead will sit a little bit offset into it's kind of going into the frame. So there is a little round edge here. You can either leave it like this. This is due to tolerances in profiles, glazing beads, and glasses. Or you can, well, it's really just a small, I see maybe 2% of people notice this at all. Those who notice it, they can adjust it. It can be adjusted. You can do it flush if you want. A matter of adjusting the magazine.
Wenn man noch kommt, mit der Bohrmaschine sind da Löcher bohren.
Das habe ich schon gesagt.
Und da können wir noch wechseln.
Okay. Then Reto will show you how to change the how do you call it? The bit to the drilling bit. So here a stepped drill bit for the stainless steel studs, or if you want to pre-drill. So there is like little aid here. It's a aluminum ring that you apply. You just put it on. Then you press the lower part of the magazine, and with the pliers you just pull it out. That's it. So it kind of releases the spring that holds the drill bit in place.
Okay.
And again, drill bit goes in, you press it in, and that's it. And now you can drill. So it's a drilling and screwing machine, or screw gun.
Color to send the machines. Also got color.
So here again, you can work with the stepped, also the limiter. What do you call it? The limitation. You can work with the magazine or without. It's up to you how you do it. What is the depth of the drill? Both methods are possible, both ways. But again, we don't need the drill bit. We just need the what is it? Phillips drill.
Yeah.
So it goes back in. That's it. Magazine is set on 9 millimeters. Okay, there is a spring. It's spring loaded. So we have magazines of 10 screws. They go in like so. You head up, bottom down, then you disengage the screw, and it's it. And it will just automatically move. You have 10 studs now to set. We have already marked the distances here, 70 and 300, and we will set the studs. The setting methods is actually pretty simple. It's shown in the documentation. You can turn the magazine the way you want. If you can't access the corner, for example, if you don't have the space for the machine, you can turn it sideways, and then you have more flexibility. There is a little arrow here. I don't know if it's visible, which shows you the center of the head of the screw. So this is your reference point. Should be on the mark, and all we do now is set the screw, set the stud. Important to keep it straight or perpendicular, 90 degrees. Press firmly, and then remove to the side. Tilt it to the side at the end. And then you see, Reto tilted it to the side. This will save actually the magazine. This will save the parts in the inside, because there is no friction on the head of the screw when removing the magazine or the turning tool. Again, remove to the side, next side. And that's it. Then you finish the whole frame. It's pretty easy, pretty fast. If the depth of the stud is also predetermined, it should be sitting right where the little recess begins. There is a little, what do you call it? I don't even know the right name. It gets a little, well, there is a little, what is it, stopper, let's say. So this is the perfect depth of the stud. If it doesn't go deep enough, adjust the magazine, adjust the depth. If it goes too far, if you hear the clutch, let's say making too much noise, then it's probably too deep. Then again, adjust it. But it's really easy. It's not really, if you know how to drill in steel, you will know how to adjust it. Glazing beads, again, there is different thicknesses and different materials. We will take the raw stainless, the raw steel glazing beads that fit to the thickness of the glass that we have chosen. Janisol can take up to 40. Was ist das? 47, ne? Beim Janisol kannst du machen. Glasdicke. 47 is the maximum depth you can glaze on the Janisol 2. In this case. Then again, our plastic hammer. This is the easiest way to do it. If you now click the glazing bead on, don't hit it flat on this side. You may deform it. Tilt it a little bit and hit the corner, hit the side where you have more support, more force transfer to the screw. That's it. If you're not sure, or if you don't have a plastic hammer, then you can also use a little device. Oops, it's the other way around.
Sticky note.
A stophout.
That's it. So here, if you want, if you wish, again, you can do some adjustments, but really this is almost flat. Yeah, the wood, the jig, Swiss wood, item number 550. No, I'm kidding. It's just a piece of wood. Okay, so that's done. Now we have glazed the leaf. Everything is in place. This should be it. Now the last thing would be the gaskets. The gaskets going on the. Actually, no, wir würden das ja vorher ankleben, oder? Die,
auf der Seite ist Lappenseite kleben.
Aha, and here genau. The inner side, the flange side of the profile. This is where you glue the gasket on. It's a self-adhesive gasket. On this side here, you would insert it. If you were working on with a dry glazing with gaskets, so you would just push it in using a thin stainless steel metal sheet, or yeah, even without it. We'll just give you a little more detail on that. So just a few words on glazing. Dry glazing means using gaskets, not the silicone and distance tape. Both glazing methods are possible with all our systems, and of course there is different philosophies. Either dry glazing or wet glazing, silicone glazing. Some metal workers prefer the one, some the other. Both have some disadvantages and advantages. Dry glazing is faster, it is cleaner, but I hear that it may not be as watertight sometimes. I hear it. Okay, silicone is a glue, so yeah, it makes sense. It may actually cover the gaps, but I think the differences are minimum. We have tested all the system with both glazing methods, so we leave the choice to the metal workers. But so just that you know, I hear a lot of discussion about this, and even the metal workers among themselves, they like to, philosophize what is better, what is faster and more efficient. In hot countries, I hear dry glazing is better. The gaskets do not, let's say, react so much to the heat or the sun radiation as a silicone. So yeah, hot climates, dry glazing seems to be the better choice. But again, it's a matter of
I think
custom.
one of the challenges with the wet glazing is you need the skill to apply it to make it neat.
That's true. Also, yeah.
People are not very good at it.
That's true.
Most.
Yeah. Mm-hmm. Okay, so any questions at this point? Any other comments? Or are we good?
No, is that good?
All right. Then let's move to the openings, to the notching out of the openings that we need for the lock and the rest of the fittings. We did it already on the mill. We have an opening for the cylinder fastening of the rosette or the cover plate. This is the opening for the handle, both sides, of course, and this is the notch out for the lock. These openings can be done either on the CNC machine, which is fastest, or on a copy mill, or you can do it actually using the drilling jigs for each system. We have a set of drilling jigs designed for well, different functions. So one would be for the lock and the fittings, or lock and the handle. The other would be for the hinges and so on. All in all, there is I think some 400 drilling jigs in the Janssen program. Some of them are here. I think if you have maybe 10, then I think you can cover some 80% of all the applications. So it's again a matter of choosing the method how you work in your workshop. All the dimensions. So if you wanna do it by hand, just by measuring, you can do it. All the measurements dimensions are given in the documentation. Then again, you have the type of lock, the item number, and then the assembly instructions for each type of lock. Yeah. So it goes log by log, log by log. Here the additional fastening to the top. You see the additional latch, the extension rod, then the reception part, electric dimension, electric opener. This would be the sill detail, drainage pipe, drainage sleeve, and so on. All the steps are in there. And by the way, many of these steps you can see on the videos that my colleague Manuel uploaded on the DocuCenter.
Okay.
If you work with the drilling jigs, which let's say the beginners often do, it's important to match the item number of the lock. It's on the box always, with the drilling jig. The drilling jig is actually tells you which. I don't know if this is visible. There is letters and symbols B1, B2, B3, B4, and it tells you B1, for example, 4 locks with cylinder this and that. So it will tell you what item numbers can be done when you drill, or what locks by item number can be installed drilling the holes B1, B2 for this type of locks, B3 for that, B4 for that. It's always a range of locks. So item numbers go from, let's say, 814 to 827. So there are several locks where you would drill the B1 holes. And B1 holes are marked. So here, for example, again, this is visible. Here you will see the symbols B1 and B3. So this is the hole, for example. This would be the B2 hole, and so on and so on. So it's always the same system. Just go by the symbols and match it with the item number of the lock, and you'll be on the safe side. Okay, so before we notch out, we position the drilling jig. There is always a line, the so-called GMAS, or the X, I think it's called in English. This is the height of the handle, the center of the handle. Yeah, so this is what we kind of refer to when we start the notching out, our reference point.
Okay.
So that's what we align. So we would mark it on the profile. We would mark the X on the profile. We know the height of the handle, and then we position, we clamp the jig on top. And then, now depending on the lock we are installing, drill either B1, B2, B3, or B4. After drilling the holes, the holes are not all you have to do. If you look at the drilling jig a little closer, you will see lines, these notching outlines. So the holes, the perforation is actually only your reference point between the holes you have drilled. You need to now mill it out or cut it out. That's how you do it. So the holes are just a reference point.
Okay.
The milling machine uses the milling bits, standard size. This is say, what is it, 28? This is a 22. So standard width of the lock is 22. So for that, then Janssen actually has all these tools in the portfolio as well. You can either buy them from us or just on the free market. It's either way. Just the sizes have to fit. That's for the handle, 24. Then for the profile cylinder, there's two types of cylinders here in Europe. For this one, we have these two. So it's an 11 mm and das ist 18, 11 mm. And once you've drilled the holes, you just connect them with a little hand mill or a grinder, whatever. Handfräse, no? Yeah. So that's how we do it. Just for our purposes, we didn't. If you were here, we would do it now all on the mill. But I think it doesn't. Yeah, make much sense. You kind of follow what happens here. Now the next thing is the insertion of the lock. It should fit, and we also have the positioning screws. The openings. Kannst du das nochmal rausnehmen? So you see the screws where the lock will be fixed. So once you've inserted the lock, make sure that the cylinder fits fine before you screw it on, before you fixate the lock. You can check the functions, and once this works fine, then insert or fasten the first screw. Yeah. The locks, as I already mentioned, they are in the process of being, the whole portfolio is actually being redesigned right now. Less item numbers, more functions, better locks. We're changing suppliers. All the locks in the future will be equipped with a QR code, so you can basically just scan it, and the code will give you the type of lock and possible replacement parts, whatever you want. So it's the digitalization is entering the lock world as well. The screws to fasten the lock, you have them here. These are self-tapping screws. No need to cut the thread. The drill bit is a so-called SR1 code. It looks, the screw looks like a Phillips screw, but it is actually designed to fit the square tip of the bit. And what happens here is just the mechanical strength will keep the screw in place. It's not a magnet. It will stay on the bit, so it makes it easier. It's just mechanical, the different shape of the bit, called SR1 here in the Janssen. That's pretty easy, yeah. Okay, the last thing is the handle. Here again, 2 screws for the cover plate. Then we'll turn the cover plate, click it on, and it's done. That's it.
Natürlich noch eine Abdeckung für Projekte.
Then there is a cover plate for the locking, let's say, wheel.
Das ist auch für die Abdeckung gibt's noch, oder?
Yeah, that would be still a part that goes in between. We didn't do it now for,
Yeah, no.
but you can imagine. I guess it just covers the holes and makes it all nice. All the locks and handles are marked. Janssen, they have the Janssen logo of them. Well, we can discuss about the design of the handles. It's not the sexiest handles I have seen in my life, but what they do is they follow the norms, and especially the 179 norm for panic doors. So the way these all the handles at Janssen are designed, the design respects the requirements of the norm, meaning the space between the door and the handle itself. It has to be big enough for any hand. The angles on the handle are also defined. They should not be too sharp. They shouldn't be too round. Then this recess here, you see, this is to accommodate your thumb. If you are to open the door, it's dark and you are in a hurry, and there is a fire behind you. You don't want to open the door and smash your finger, your thumb against the frame. That's why you see the offset here, like so. So all these little details have a reason, but in some they do not resemble a nice, attractive handle. The handles are a free choice of the metal worker. We have the basic, let's say, basic portfolio, and that's it. Okay.
Wunderbar.
All right. Okay. What's the time? 4 o'clock almost. Anything else, guys, that we can show you here in the workshop?
No, I think you've shown us all the toys. I think it looks good.
Okay, let's maybe, Reto is just suggesting we'll have a look at the panic doors. One last thing that will close the circle that I opened today.
Okay.
So here you see the different panic functions that we have. So this would be the standard handle for semi-public buildings. For the public buildings, we have since this year we have this vertical bar, push bar. This I didn't have in the presentation. This is a new product. Makes the whole thing much nicer, I would say, looking much nicer, and works also for public buildings.
Wow, that's beautiful. Huh?
This would be a double door, or double leaf door, two handle on both sides. And here again, you see the function of the recess to protect my finger. When I open it, when I push it, I don't hit the frame here. Okay, then what else? Panic E. This would be the panic function E. Handle on one side and a knob on the other, not movable. Okay. So just getting out of the building, and then not again in.
And then to
Key
get
entry.
Yeah, to get to the knob, you actually hold the key.
Yeah. That's basically it. Maybe here about the push bars. We have two types of push bars in the program. One is let's say the standard one, and one is this push down bar. Both follow the public norm, the 1125 here in Europe, so both can be installed. Yeah, that's it. Really, this is our test windows from the FB test, FB4. So Magnum gun 9mm. This is a cladded door, FB3. So it's actually like a mid-size handgun, also 8 to 9mm. And this would be an FB6 door, a small sample door. So machine gun, AK-47, Kalashnikov, and you see this is basically a different construction. It's our profile equipped with thick flat steels all over the frame. So here we do a lot of additions, welded hinges, special steel. The glass is, of course, I don't know how thick, 70mm, several layers, glass and plastic, I guess. So yeah, compound glasses. This is what is used for the FB class.